Good morning. We are going to be looking at sections 1.1 and 1.2, the first two sections from our book. These first four problems you should be able to do on your own because this was similar to what was on your homework. So if you want to pause it, attempt those problems, and then come back to check your answers, that would be great. If not, we are going to chug ahead. So the first one is saying to name our line over here in 7 different ways. And what they have done beautifully for us is demonstrated the correct symbol and number of letters. So when we're naming a line using points on the line, we have to use our line symbol and 2 of the points on the line. Now the order does not matter, and so remember we're going to be looking at 7 different ways. So I'm going to go ahead and number so we can keep straight how many we have done so far. And starting with number 1, they gave us one of them in the problem, line PR. Now remember, because the order does not matter, I could also say line RP. And so those are the 2 ways using those 2 points, R and P. Now there are other points on the line, so I could use P and Q. So that could be line PQ or QP. I could also do QR or RQ. And what's very important is that I have the correct symbol above so that we know we're talking about a line. So those first 6 ways are how I can name it using points on the line. The 7th way comes from that scripty, cursive-y looking letter above. And if I'm going to name it with that one, that's when I use the word line and then that lowercase letter m. So there are my 7 ways. Okay. And then still referring to the same diagram, number 2 is saying name segment PR, and again they've demonstrated to us the correct symbol and 2 letters. So we're going to name segment PR in 2 different ways. So that first one they've already given to us in the problem, segment PR. The second way is it could be segment RP. And those are the only 2 ways we can name the segment because we have to use the endpoints of that segment. So for a line, you have more options than for a segment. Now we want to name Ray PR by 2 letters in 2 different ways. So they've demonstrated again for us the correct symbol and number of letters. So remember, the starting point has to be first. So here is Ray P, and if it's going off to infinity through R, one way to name that ray is PR. The second way would be to name it by ray P first, again, because that's the starting point, Q, because if it's going to go off to infinity through Q, it's still also going to pass through point R, so it covers the same space. It's the same ray. And then lastly, we're looking at an angle here. How many angles are shown? Well, I've got angle 1, angle 2, and then the angle formed by combining those 2 together. They're adjacent, they're touching. So I have 3 angles shown, and let's name them. So one of them is angle 1, or I could also name that angle ABD, or angle DBA. Remember, the vertex is always the middle letter, so this is one of our angles. The second angle, again, I've got angle 2, I could call it. I could also call it angle DBC or angle CBD. And again, the vertex is always that middle letter. Our third angle is the one formed by combining angle 1 and angle 2. And that one doesn't have a number to name it by, so I can only call it either angle ABC or angle CBA. So this is multiple names for one angle, multiple names for our second angle, and multiple names for our third angle. So again, this was all review from our naming lesson that we went over and your first homework assignment. What we're moving into now at the bottom is new material, and this is called intersection and union problems. So what we first need to review is the different symbols. So what looks like a little upside down U, this means intersection. And this means, what do they share? What do they have in common? Where do they overlap? The capital U means union, and that means, what do they form together? And so what I'm going to be doing is I'm going to put my paper in a dry erase sleeve, and my reasoning for that is so that for each of these different problems, I have a clean slate to work on, and you'll see why that matters here in just a moment. So I'm putting this in my sleeve, and I'm going to be drawing and erasing over it each time. So let me get it to where the glare is not too bad. Let's see. Okay. So, starting with number 1, I'm looking at an intersection. That symbol upside down looking U, that means intersection. Where do they overlap? And I'm looking at segment AD and segment NE. So I'm going to draw segment AD green on my diagram. There it is in green. And then segment NE in red. And so for an intersection, I'm looking at where do they touch? Where do my green and red touch? And that is right here in the middle at point O. So the answer to that is simply point O. So capital letter O. Okay. Now I'm going to erase that because I have a new set of unions I'm looking at on part B. And this one is asking for 2 rays. So remember, union means what do they form together? So looking at my first ray, I'm going to do that one in green, ray OA. So that means it's starting at point O and then going off to infinity through A. My second ray OD is also starting at O and going off to infinity through point D. So union means what do these 2 rays form together? Well, one thing that they're forming is a line. I now have a straight line going off to infinity in both directions. So this could be line AD, AO, OA, OD, DO, however you want to name it. I'm just going to go with AD. Another way you could name that geometry is that this is actually forming a straight angle. If it's equal to 180 degrees, it's a straight angle. So you could also say angle AOD or DOA. But line or straight angle there, both are acceptable. Again, I'm going to erase and move on to part C. I've got ray OD, so I'm going to draw that one back on there. Starting at O, off to infinity through D. That one is my green. And then OE starts at O and goes off to infinity through E. And I'm looking at the union, so what do they form together? Well, these 2 rays have formed this angle. So again, I can call this angle by 2 different names. I can either call it DOE or EOD. Either of those is correct. Remember, we cannot simply call it angle O because I have multiple angles with O as the vertex. Okay, on to our next one. I'm looking at an intersection, and this time I have line NE, so I'm going to draw that one in. Line NE, that's my green, and ray ON. So starting at O and going off to infinity through N. So if it's an intersection, I'm looking at where do they overlap? Where do green and red touch? And that is going to be from O through N off to infinity. So the answer is actually this ray ON. And then last one on this front page. If I'm looking at part E, again, I am looking at an intersection of 2 segments. So my first one in green is going to be segment AN. And then my other one in red is going to be DE. And if intersection is asking where do they overlap, what do they share? Do green and red ever touch each other? And the answer is no. So when there is nowhere that they intersect, then we are going to put a 0 with a slash through it, meaning nowhere. Empty set is what that notation means. Okay. So I'm going to go ahead and take this back out of the sleeve so we can move on to the back page. Sleeve, I've written down our answers in pen now, and one way you could do this if you don't have a dry erase sleeve at home is just redraw the diagram multiple times, because when you're drawing with multiple colors over the same spot over and over, it can get a little messy. Okay, moving on to the back side, we're going to look at some segments and angles now. So starting with this first problem, I'm told that angle DEG, so this whole big angle here, is 80 degrees, and that angle DEF, this one on the inside, is 50 degrees. Then angle HJM, this big angle on the right, is 120 degrees. And angle HJK is 90 degrees. So what conclusions can we draw about angle FEG and HJM? So what we're looking at is this angle here, FEG and HJM. Well, one thing I know I can figure out is what are those angle measures? Angle DEG is formed by DEF plus FEG. So that means if I subtract 50 from 80, I'm going to find that missing angle measure to be 30 degrees. Same thing over here. HJM is formed by HJH and HJM. So I can find that missing angle by subtracting 90 from 120. And would you look at that? It's also 30. So what does that mean? If both angles are 30, then that means that they are congruent because they have the same measure. Okay. Again, looking at example 2, ABC is a right angle. If it's a right angle, that means it's equal to 90 degrees. Angle 1 is 3x plus 4, and angle 2 is x plus 6. Find the measure of angle 1. So this is going to be an algebra problem. We need to write and solve an equation first and foremost. Well, angle ABC is formed by angle 1 and angle 2. So if I add up my two expressions, that should be equal to my 90-degree angle. Now this is just algebra. I'm going to combine like terms. 3x and x is 4x. 4 and 6 is 10. And now I'm just left with a two-step equation. I'm going to subtract 10, 4x equals 80, divide, and I get that x is 20. Now the problem is asking me for angle 1, so I'm just going to plug that 20 in for x. So 3 times 20 plus 4, that's going to be 60 plus 4, so angle 1 is equal to 64 degrees. Okay, and then last but not least, we are looking at restrictions on angles. When you see the word restriction, you need to know that that just means we're writing an inequality, and we practiced inequalities on your very first homework assignment from day 1. So looking at angle B, if angle B is acute, the restrictions on that angle means that it needs to be less than 90. So the measure of angle B has to be less than 90. But in the same token, it has to be a positive number. So it needs to be greater than 0. So when you see restrictions, that means we have a compound inequality, something on both sides. Now, what are the restrictions on x? This comes from the expression we're given for the angle inside here. So what I'm going to do is replace the measure of angle B with that expression. So starting with the same inequality, I'm just going to replace angle B with 2x plus 14. And I'm just solving this inequality, which again, you practice on your first day homework. So I'm going to subtract 14 from all sides first. And then I'm going to divide everything by 2. And my restrictions on x are that it has to be greater than -7, but less than 38. And x has to be between these two values in order for angle B to be positive, but smaller than 90, which makes it an acute angle. So restriction just means inequality. And that wraps up our first two 1.1 and 1.2 section notes.